In 15.5, we're going to find percent of increase and decrease. Let's start just by talking about percent of change. Percent of change is the amount a quantity changes, or the percent a quantity changes from the original amount. So the percent a quantity changes oftentimes these problems are two-step problems. So let's take a look at one. Let's say you have 25 penalties decreased by 32%. So we're going to use a proportion like we've been using. I see that I have a percent, so I know the percent's going to go over 100. The 25 is the whole amount of the penalties we started with, or the original amount. That word's going to come up later. So it's the original amount. We're trying to find out the new amount when it's decreased by 32%. So the 25 will go in the whole, and we are finding the part. So let's figure this out. You know it's 100 times x, which is 100x equals 32 times 25. Do that quickly over here. 32 times 25, 10, 16, 4, 6, 0, 10, 8. It's 800. I divide by 100 on both sides. Dividing by 100 is moving the decimal 2 spaces over, so x equals 8. So the thing is, the answer isn't 8. When you look at this problem, it says 25 penalties decreased by 32%. So my first step was to find out what the 32% was. Now what I have to do is, in my second step, I have to take those 25 penalties and decrease them by the 8. 25 minus 8 is 17. And now I know that my answer is 17. So if I have 25 penalties, I decrease the amount by 32%. I have 17 penalties. So you have that second step that you have to worry about. It's not always going to be subtract. Sometimes when you do these problems, this word decreased will be increased. So when the word is increased, you're going to add instead of subtract. Okay, so that is if they give you the percent. The second thing we're going to be talking about is when they don't give you the percent and you're trying to find the percent of increase or decrease. The example we did just here, that 32% is a percent of decrease because our original amount 25 went down. So when you're looking at the two ideas together, if you have a percent of decrease, and I'm sorry it's the second one written, but it means the original amount went down. A percent of increase is when the original amount goes up. So we're going to, in these next problems, find the actual percent instead of the number, the part or the whole. There is a proportion we're going to use for this. That's what's so nice about these percent problems. The proportion has the exact same thing on the left side. You take the percent over 100. On the right side of the proportion, you have on the top your amount of change So like in the last problem, that number turned out to be 8. That was your amount of change because it changed by 8. And on the bottom, you have the original amount. So let's check out an example here. So let's say we're going from 10 gallons to 24 gallons. The first thing we need to do in any of these problems is find the amount of change. Now let's think about this. The amount of change goes from 10 to 24. So what do we have to do to actually find that? We subtract. Every time you're finding the amount of change, you are going to subtract the two numbers to make sure that you know exactly what it changes, the amount that it changes. So step 1, I'm going to do 24 minus 10. Now I know we can do this one in our head, but sometimes you won't be able to. And it's good to show the steps in your notes. So my amount of change is 14. The second step is to solve the proportion. So now we're going to plug it in and solve the proportion to find the amount of change. So let's think about this. The left side of the proportion is always going to be the same in these problems because we're finding the percent of change in all of these problems. So it's always going to be x over 100 because that percent is what we're trying to find. The top number is going to be what we found in step 1, that amount of change. That will be 14. The bottom number has to be the original amount. Now that's the hard part and what people mostly get wrong. Oftentimes they always want to use the bigger number. You have to remember that we always don't start with the biggest number, especially in this one because this one's an increase. So since it's an increase, you know we started with a smaller number. So the bottom number, the original amount, is what comes first. So like in a story problem, if they're using dates, you have to use the number that came earlier in dates. So in this case, we went from 10 to 24. So my original amount was 10. So now I'm going to solve it. 10 times x is 10x. 100 times 14 is 1,400. Divide by 10. Divide by 10. X equals, dividing by 10 is moving the decimal one space over, so 140. You have to remember that you're finding a percent of change, so it's 140%. Your answer should always be written with the word increase or decrease. Since 10 to 24 is an increase, you write 140% increase. So this one turned out nice. You should understand that it's 140% because it more than doubled. When you double a number, so like go from 10 to 20, that's 100% increase. And since 24 is more than 20, it should have more than 100% increase. Now the answers aren't always going to turn out perfect. So just so you know, when you're doing percent and increase and decrease, we want you to always round to the 10th. So in your division, you will have to divide to the 100th so you're able to decide if the 10th will round up or stay down. All right, so let's do one more example in this and one story problem, then I'll be done. Let's say we're going from 68 miles to 45 5/10 miles. My first step, again, is to find our amount of change. So I'm going to do 68 minus 45.5. Remembering we got to line up our decimals. Borrow. 10 minus 5 is 5. Decimal comes straight down. 7 minus 5 is 2. 6 minus 4 is 2. So my amount of change is 22.5. My second step is to write my proportion. I know I'm always finding the percent in this case, so x over 100 equals, my amount of change was 22.5, and my original amount, I started with 68 miles, is 68. So let's solve this. I do 68 times x, which is 68x equals 100 times 22.5. Move the decimal 2 to the right for multiplying by 100. 2, 2, 5. 0 goes in swoopies with nothing. And I'm going to divide by 68. All right, so I have 2,250 divided by 68. I need to do my multiples of 68. So I have 68, 136, 204, 272. Okay, I'm going to stop right there just because I see my first one. So 68 into 225 is 3. That's 204. 225 minus 204 is 21. Bring down the 0. Oh, again, a 3. 204. Subtract, I get 6. I add my decimal. Now I know I have to round to the 10th, I said. So since I'm rounding to the 10th, I only need to go 2 past the decimal, because this second 0 is going to tell me if I have to round up or not. Bring down that 0. All right. 68 does not go into 60, so that is 0. And now I just need to know how many times 68 goes into 600. So I really just need to know if it's going to be more than 5 or less than 5, to tell you the truth, because if it's 5 or more, I know that 0 is going to round up to a 1. So if I do 272 plus 68, I get 340. 340 plus 68, I get 408. 408 plus 68, I get 476. Plus 68, I get 544. Plus 68, I get 612, which is too much. So if I look at this, it is 1, 2, 3, 4, 5, 6, 7, 8 times that it goes in. So that'll be an 8. And that 8 is going to tell me to round this 0 up to a 1. So I get x equals 33.1%. And when you're writing your final answer, you write a 33.1%, and it is a decrease because the number of miles went down. Okay. So let's do one story problem so you can kind of see what that looks like, and then we'll be done. So this problem reads a little differently. You estimate the length of your classroom is 16 feet. The actual length is 21 feet. Find the percent error. While it doesn't say find percent of increase or decrease, you're still finding the percent of change in this problem. So some story problems are going to ask you things like percent of increase or decrease. It'll say things like, you estimate that 200 people attend a school concert. The actual attendance was 240 people. Find the percent of increase. Like, it'll actually ask you to do that. And this is just a different way to say it. So you still have your first step. Your first step is to find the amount of change. In this case, it's 21 minus 16. That gives you 5. Your second step then is, you know, you're finding your percent of change, which is error in this time, or increase or decrease. The amount of change you found was 5. And then the original amount is what you, is different as far as percent of error goes, because in percent of error, you have to put the actual amount. So in this problem, the actual amount is 21 feet. So you have to write 21 in the denominator. In a percent of increase or decrease problem, you have to make sure you put what came first in time. In this problem, percent of error, you have to put what the answer actually is. Okay, so let's solve it then. So this x, this percent is actually an x, because that's what we're finding. 21 times x is 21x equals 5 times 100 is 500. I'm going to divide by 21. So I have 500 divided by 21. Goes into 52 times, that's 42. Subtract, I get 8. Bring down the 0. I know it's not 4, because 4 times 20 is 80, so it's going to go 3 times. That's 63. Subtract, I get 7. I'm going to add a decimal and 2 zeros, because I know I have to round to the 10th. 21 into 70 is going to be 3 times again. That's 63. Subtract, I get 7. This one's going to repeat. I don't write repeating things in here. I'm still going to round. This 3 tells me to round the 1 in the 10th to a 3. Ooh, I messed up. Okay, so in my hurry to get this done before the school day started, I subtracted wrong. So let's go back and erase this part of the problem. And know that 80 minus 63 is not 7, but 17. Still going to bring down that 0. Sorry about that. So you get 21 into 170. 21 into 170 is 8. That is 168. Subtract, you get 2. Bring down the 0. 21 into 20 is 0. So that 0 will not round that 8 up to anything else. That 0 will keep that 8 and 8. So x equals 23.8%. So you would say the percent of error is 23.8%. All right, you're going to try this out on your own. Please ask questions if you have any. Sorry about the mistake, and good luck.